VLAN produce fascinating systems. The AGC electroforming technique. Nowadays, crowns and bridges, implant-borne restorations, fixed, removable restorations, as well as inlays and onlays have to be highly biocompatible and also very aesthetic. As electroforming uses pure gold and porcelain, it complies with these requirements extremely precisely. The AGC Micro, AGC Micro Plus, and AGC Speed series is based on the experience and know-how which VLAN has gained in the use of dental electroforming in dentistry since 1986. The AGC Micro and AGC Speed system present the advantages of pure gold restorations in a new compact unit. The AGC Micro, AGC Micro Plus and AGC Speed are compact, attractively designed and easy to use. They produce very reliable results, their personnel and operating costs are low, and they make economical use of the electrolyte. The AGC Micro can electroform 6 different restorations and the AGC Micro Plus 16 of the same thickness during one procedure. Due to their modular design, these units can electroform the number and type of restorations required. The head is easily removed to insert the restorations. The beakers are also quickly exchanged for electroforming various numbers of restorations. Each restoration can be supplied with the current it requires. This guarantees uniform thicknesses of 0.2 or 0.3 millimeters. Both units include a serial computer interface for documentation purposes. The use of 3-dimensional models to determine the electrical current setting is the only aspect of the previous system retained in the AGC Speed. Electroforming times are incredibly short. For example, only 75 minutes would be required to give this restoration a thickness of 200 microns. Everything else is new. Each electroforming cell is intended for a single unit and consists of an anode head, an electrolyte container with a magnetic mixer, and a holder for the restoration. The gold solution does not have to be measured, as it is supplied pre-packed with sufficient solution for electroforming a single unit. The gold solution is poured into the electrolyte container and a brightener, which is also supplied pre-packed, added to the solution. Each electroforming cell has its own element for heating the solution, which is regulated by 2 pyrometers. Units are held by reusable titanium rods instead of conventional copper wire. The chuck is opened by turning it twice. The titanium rod is inserted and the chuck tightened again. Gold precipitation begins when an operating temperature of 65 Celsius is reached. Precipitation can be observed in the illuminated electrolyte container. The AGC Speed system is a modular system with extremely short electroforming times of only 1 or 2 hours. The VLAN AGC system is reliable, easy to operate, and economical to use. The VLAN AGC system provides for exemplary biocompatibility. Restorations made of pure gold and porcelain are certain to avoid allergic reactions. If the correct procedure is followed, the AGC system ensures an extremely accurate fit and perfect margins. Rarely has any other materials technology been so comprehensively researched, both scientifically and clinically, as the VLAN AGC system. Studies have proved exceptional durability, especially in the posterior region. An extensive bibliography is available. radiant gold color of electroformed restorations creates a basis for aesthetic and naturally attractive teeth. The Wieland AGC system has a wide range of indications: crowns, bridges, telescopic restorations, implant-borne restorations, inlays, onlays, denture bases. The procedure. Electroformed crowns require a deep chamfer or shoulder preparation. Inlays require a box-shaped preparation. The master model is cast as usual. Any model system, pins or trays can be used. The dies must be checked for undercuts and then duplicated. The die should be blocked out with AGC blocking out wax. If crowns are being fabricated, it is advisable to apply die spacer to create adequate space for the cement. Inlays can be stabilized by waxing cross-shaped ridges onto the cavity floor. It is advisable to pour an additional model for the fitting of inlays and onlays. Model dies should not be blocked out with light curing resin. Dies should also not be coated with superglue, grease or oil, as they might cause an adverse reaction, especially with one-to-one duplicating material, which would compromise the accuracy of fit. AGC Dubligum duplicating material is mixed in a ratio of 9:1 for 40 seconds in vacuum. A thin stream of duplicating material should be poured alongside the dry die in the flask. Once the setting time of 30 minutes has elapsed, compressed air can be used to remove the dies from the mold. The duplicating mold should then be sprayed with AGC neutralizing agent. After 30 seconds, blow dry with compressed air. Dies for electroforming should be cast with AGC extra hard stone. Mix for 30 seconds in vacuum. AGC extra hard stone expands by 0.08% and is ideal for all types of AGC restorations. The duplicate die should be removed from the mold after 30 minutes and dried in a microwave unit at approximately 210 watts for 1.5 to 2 minutes. Once dried, the duplicate dies must be trimmed as small as possible. Sharp line angles must be rounded to create a shape which is easily flowed around. The duplicate die must not be adjusted with wax or resin. Electroforming can also be carried out on resin dies, though not in AGC speed units. A 1 mm tungsten carbide twist drill is used to drill a 2 to 3 mm deep hole 1 mm from the preparation margin. And an AGC copper contact rod is then glued into it. Only apply a small amount of adhesive so that no excess remains. Excess adhesive insulates and must be removed. The AGC conducting silver lacquer must be shaken well before use. The conducting lacquer is then applied uniformly to the preparation margins. Blank areas must only be coated with minute portions of lacquer, because several overlapping layers would affect the precision of fit. The surface being electroformed must be connected to the AGC copper contact rod. The AGC conducting silver lacquer must be allowed to dry for 15 minutes before beginning electroforming. A heat shrink sleeve is then slipped over the copper contact rod to within 1 mm of the stone die to insulate the rod. It is then shrunk into place with a hot air source. The die must not be placed directly over the heat source. The sleeve must not be shrunk into place with a flame. This stage is unnecessary if copper contact rods are used where the sleeves have been shrunk on in advance. The correct current setting is obtained by comparing the restoration being electroformed with the samples shown on the table. The current setting depends on the surface area of the restoration being electroformed. The currents and positions should be noted down for programming the AGC unit. As the gold solution is only used for one electroforming session, the unit calculates how much is needed, which then has to be measured out. This ensures that the solution is used very economically. It is better to note all values on the chart. If larger components are being electroformed, several copper contact rods must be fitted. The currents and amounts of gold solution are added up. The two abutment copings correspond to this sample, which requires current setting 7. The surface area of the bridge framework is the same as that of a molar, that is, current setting 6. The thickness of the layer depends on the time, the current, and the amount of solution. To deposit an approximately 300 micron thick layer, the timer on the AGC unit should be set to program 2, that is, electroforming for 415 minutes. To produce a 200 micron layer, select program 1, that is, electroforming for 300 minutes. The current levels noted previously are then entered into the unit. The unit calculates and displays the amount of solution required. When using an AGC Micro Plus, press the Mode button to select the thickness of the layer. The thickness and electroforming times are identical with those of the AGC Micro. If the calculations indicate that less than 90 milliliters of gold solution are required, the 100 milliliter glass beaker is used for electroforming. The small magnetic mixing rod, both reducing rings, and the large spacer are used so that up to 2 restorations can be electroformed. If between 100 and 220 milliliters are required, the medium magnetic mixing rod, the large reducing ring, and small spacer are used. If more than 200 milliliters are required, the large magnetic mixing rod is used with the 600 milliliter glass beaker and no reducing ring or spacer. Even if the table indicates that, for example, 28 milliliters of gold solution are required, the minimum amount of 50 milliliters must be added. Otherwise, the restoration would not be covered with sufficient gold solution for electroforming. Once the correct amount of gold solution has been measured out, it should be poured into the glass beaker, the correct reducing ring inserted into the hot plate, and the glass beaker placed on it. The anode must contact properly. As the anode contains a glass pyrometer, it must be handled carefully. The copper rods should then be pulled through the appropriate openings and the restorations aligned with the arrows on the head. When using an AGC Micro, the 6 outer holes should be used for the large glass beaker, the 4 central holes for the medium beaker, and the 2 inner holes for the small beaker. The AGC Micro Plus uses 4 different glass beakers. If 16 restorations are to be electroformed simultaneously, the 4 holes in the second ring and the 12 holes in the outer ring should be used. If the 1000 milliliter beaker is filled with more than 551 milliliters, the largest of the 2 magnetic mixers must be used. The correct current should be set for each component being electroformed. The locations of the restorations should be numbered to prevent incorrect settings. Once the electroforming head has been pressed onto its holder, the restorations can be positioned at the correct level. The lower edge of the stone die must not be lower than the anode. 4 mm of high luster additive are added to the gold solution per contact, that is, 24 milliliters for 6 restorations. The electroforming head is then lowered onto the glass beaker. The copper rods are then inserted into the correct contacts. Once contact has been achieved with all restorations, press the Run button. The unit first heats the solution and runs a self-test. Potential errors are displayed. For example, should a restoration not have been placed in proper contact, the AGC Micro displays 004 and the display of the station affected flashes 0 and the current level programmed. The AGC Micro Plus displays this error with a flashing lamp at the affected station. If the user does not correct the error and achieve proper contact, gold continues to be deposited, but without electroforming the restoration correctly. Both the AGC Micro and AGC Micro Plus initiate electroforming automatically once the solution has reached its working temperature. Once this stage has been attained, electroforming must not be interrupted. Once the electroforming process has been completed, the restorations should be removed from the unit. The stone die is released from the electroformed restoration with AGC plaster solvent and ultrasonics. The layer of conducting silver lacquer is retained. It has to be sandblasted out before fitting the restoration onto the model die. Clean aluminium oxide with a grit size of 110 microns is used for this purpose. The pressure must not exceed 2 bar. The conducting silver lacquer should not be spread unevenly when fabricating the outer copings for telescopic restorations, as this would create rough surfaces on the inner coping and impair the fit. This would also impair the sliding effect when fitting the restoration in the mouth. When fabricating telescopic crowns, the conducting silver lacquer should be dissolved with dilute nitric acid. A fume cupboard should be used for this, as toxic acid fumes are given off. Silicone polishers are recommended for reducing the margins which protrude beyond the preparation margins and fitting the electroformed restoration onto the die. Metal burrs are not suitable for this purpose. As there are no oxides on the surface of the electroformed framework for bonding to, the porcelain relies on physical forces and mechanical interdigitation for bonding. Mechanical retainers on the surface of the gold are therefore essential if high bond strength is to be achieved. These retainers can be created by sandblasting the surface of the framework with clean aluminium oxide with a grit size of 110 microns at a pressure of 1 bar. Tests at the University of Freiburg, Germany have shown, however, that the porcelain bond to electroformed copings can be further improved by coating the framework with a bonding agent fired at a minimum of 920 Celsius. The bonding agent consists of an organic base material, gold globules with a diameter of approximately 1 micron, and very fine dental porcelain particles. During fusion of the bonding agent, the surface of the framework and the porcelain particles are wetted thoroughly with the gold globules. This creates a uniformly rough surface, which provides the porcelain with an excellent retentive surface during firing. At the same time, the porcelain components of the bonding agent sinter with the opaque porcelain. Tests have also proved that there is sufficient bond strength between the porcelain and the framework even without using a bonding agent. Conditioning the surface with a bonding agent at 920 Celsius ensures that the surface is wetted completely, and this undoubtedly improves the bond of the porcelain to the electroformed framework. The bonding agent is only effective, however, if it is applied correctly by the technician. If applied incorrectly, the bonding agent is more likely to be counterproductive and cause the organic components to vaporize and trap air bubbles. To be on the safe side, bonding agent should always be used with AGC electroformed bridges. The bonding agent should always have a creamy consistency. Apply a uniform coating of bonding agent. Before firing, allow the bonding agent to dry long enough on or in the furnace according to instructions. The margin is then polished on the duplicate die with high luster polishers and checked on the master model. The electroformed inlay is then steam cleaned and degreased with pure alcohol. The porcelain should not be fired at more than 950 Celsius. Further indications. The AGC technique can also be used for short span bridge work. Two 200 micron thick abutment copings should be electroformed. The abutment copings are then sandblasted to enhance retention and the pontic waxed up to surround the abutments. The pontic is invested with the abutment copings and cast with the lowest fusing alloy possible. The restoration should be built up with a porcelain which matches the alloy. The pontic can also be waxed up between the non-sandblasted abutment copings, cast with a gold alloy and then soldered, or laser welded between the abutment copings. The pontic can also be adhered non-stressed to the abutment copings. Special high-temperature porcelain adhesives are available which do not harm the porcelain facings. If the pontic is to be fully coated with AGC gold, the entire model should be duplicated in one piece. The pontic is waxed up on the duplicate model and cast with a gold alloy. The abutment teeth on a second duplicate are coated with conducting silver lacquer down to the preparation margins. The pontic is oxidized, sandblasted and degreased. It is then placed on the abutment teeth and electroformed into place. The AGC technique is also indicated for telescopic crowns. The inner coping is cast and milled. The inner coping is then coated with conducting silver lacquer and the outer coping electroformed. The outer coping fits extremely well. The outer copings are silanized, adhered to the silanized chrome cobalt framework and then faced with resin. AGC double crown dentures offer excellent comfort and aesthetics. Superstructure units for implant-borne AGC electroformed crowns. Bioposts, high gold content, biocompatible, homogeneous implant abutments are available for standard external hex implants. The high gold content ensures excellent aesthetics even in the transgingival area. The abutments are pre-formed and comparatively easy to prepare. They're secured onto the implant analog or in the mouth with screws. In the dental laboratory, passively fitting AGC copings are fabricated on the customized abutments and bonded to the denture framework with adhesive. Prefabricated electroformed supracaps are available from Wieland for non-customized biopost abutments. The finished AGC crowns can be cemented or retained individually using AGC horizontal screws. Here are all the work stages once again, step by step. The selected abutment is trimmed to customize it. This produces anatomically shaped labial and palatal surfaces. The preparation margin of the die is reduced slightly. The outer coping was fabricated using the AGC technique. The electroformed coping is prepared in the usual way. The AGC coping fits passively on the abutment. The finished superstructure can be cemented or screw retained. Recycling the residual gold. Innovations from Wieland are not just limited to fabricating all types of precious metal products, for example the AGC electroforming range, but also include recycling and disposal. Wieland is therefore the only German refinery which is also certified as a specialist waste disposal firm. Wieland has developed its own very environmentally friendly procedures for exploiting and decontaminating highly toxic waste and residual materials. Wieland cost-effectively exploits and disposes of scrap metal, hazardous waste materials such as acids and etching agents, as well as electroforming solutions. Depending on the type of unit, the following options are available for reclaiming gold from AGC solutions. Separating the solutions in the recycling plants at Wieland Edelmetalle. Precipitating onto a residual gold sponge in the laboratory. And precipitating residual gold in the dental laboratory using the Wieland Gold Recovery Kit. As this chemical procedure is not carried out in the AGC unit, the AGC unit can still be used during the recovery process. The materials required are available as starter and refill packs. There is a set for the AGC Micro, AGC Micro Plus, AGC 5 Process,